So we have the data there, so we can just mute for now. So ages of president, the first step is to create a frequency distribution. So it simply means we're trying to organize this data in a better way. As I mentioned last time, there are multiple ways to create the frequency distribution. I'm quite certain that this book takes an approach that we did in the past. So regardless, we want to find the class width. The class width simply the maximum value minus the minimum value divided by the number of classes. So what is the maximum value that we have? 70. The minimum
42.
42 divided by 6, that would be 28 over 6. 4.6. Right. Now, the way the book suggests of doing this is to always round up. Of course, there are cases where you round it to the nearest whole number. So it's a matter of choice. And like I mentioned last time, not only that, some cases we would always start one below the actual data point so that the data point is included. So there are different ways, and this is the way the book goes by. So once we have the class width, we are going to start with the smallest class or smallest observation, which is 42, and the class width, which is 5, then 48, add 5, let's say 4, add 5, add 5, and 72 to 77.
The highest age is 7. Why would we class
0. There's nothing there. Good question, though.
Why did you divide by 6?
There are 6 classes. Was given the problem.
Oh, it was given.
Now we want to find the frequency. Well, let's start counting, and these are inclusive in the sense we're going to include 42 and 47. So let's see if I can count properly. 1, 2, 3, 4, 5, 6, 7. 48 to 53. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, 7, 11. 54 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 60 to 65. 1, 2, 3, 4, 5, 6, 7, 8, 6 to 6 to 7 to 1, 1, 2, 3. Pass through it. Good. Now, these values, are those class limits or are they class boundaries? Limits. So how do we get the boundary from the limit? 0.5.
I mean, minus 0.5 plus 0.5.
Right, subtract 0.5 and 0.5. And what is the purpose of doing that?
To get it exact for the graph.
We want to make it continuous. We don't want space in between. Is that right? Jules. So Jules asked, well, if we're going to do that anyway, why can't we just stop it at 48 and start at 48? Another way of doing frequency distribution. So, you know, as I mentioned, in practice, we're not going to, you know, group it. The computer is going to automatically do it for you, especially when you say 6 classes and so forth. Higher level programming languages like R, you have a lot of flexibility. If you use Excel, it will choose the optimal method and it'll just give you the graph. Right, so we're not going to do this manually in practice. So how do we find the relative frequency?
Frequency divided by the amount.
Frequency divided by the amount. So in total, we have 11, 22, 32, 38, 45. So 7 over 45, 11 over 45, 15 over 45, 8 out of 45, 3 out of 45, 0. What would we get if we add them all together? The relative frequencies. Okay, 1. If I add all of these together, I'll get 1. Excuse me, 45. If I add all of these together, I'll get 45 over 45, which is 1. Okay. Cumulative frequency. So how do we find the cumulative frequency? Exactly. So for a given class, we're going to add the frequency of that class and everything below it. So typically, when we draw the empirical CDF or the ogive, the y-axis is cumulative probability. But your book seems to not make a difference. They either use the cumulative frequency or they use the cumulative probability. In practice, we use cumulative probability. Why is that? Probability is the most important measure in statistics. Everything revolves around probability. Likewise, compared to frequency, we always use relative frequency. I often have students asking me the question, well, should I leave it as a fraction or should I put it here as a decimal? So in practice, decimals, always, from a practical standpoint, I love fractions, but I can't say, okay, the chances that a president would have an age between or from 54 to 59 is 16 out of 45. Do you think people would understand? No. But if I converted that to a percentage, that's probably about 36, approximately 36%. And if I say, okay, there's a 36% probability or chance that it would be between or from 54 to 59, That will make better sense. Yes. So, which is why we write it in decimals. So for cumulative frequencies, we start with this class, add everything below. So 7, everything below. Nothing's there, 7 plus 0. 11 added to the previous value, 18. 16 added to the previous value, or add all of those, that's it all. 8, add all of those, 42. 3, add all of those, 45. 0, add all of those, let's still be 45. Yes. And what is the cumulative probability? That's just 1. If we add all the probabilities, of course, we can also add to 1. Good. I don't need the starter anymore, so I'm going to get rid of it. Did we copy this part? I'm going to ask you to create a relative frequency polygon and an ogive using a calculator in a bit, but let's just do a frequency histogram. What should we do if we want to do a frequency histogram? What do we need?
The decimals on the bottom.
Which is called, which are called?
Relative frequencies.
No.
Class limit, class boundary.
Limits or
Or
boundaries?
boundaries.
Boundaries. So 42.5, 47.5, 53.5, 58.5, 65.5, 71.5, 77.
558.
To 59. Yeah, I just wanted to make sure if you guys paid attention. That's my excuse. 5, 10, 15, 20. You can either use a frequency or you can use relative frequency. The shape that you get will not change if you simply change the y-axis from frequency to relative frequency. I'm just going to use frequency because it's easy to interpret. So first we have 7, then 11, 16, 8, 3, and 0. Good. That is frequency histogram, or simply a histogram. But so far, do we see a pattern? The vogue of statistics, right? A bell-shaped pattern, normally distributed. So majority of them, lie in the middle. If I asked you, what is the probability that majority of US presidents have an age less than or equal to 65.5, would you agree with that statement or would you disagree with that statement? the majority of US presidents would have an age that is less than or equal to 65.5. Would you agree or disagree? Agree. Why is that? If I put that line over there, majority lies there, most of them here. Now, what are the chances that, based on history, that we will see someone over the age of 65.5? Very small. It has happened, but very small. How about someone becoming a president at the age of 30? Very small, impossible. It is impossible. I have better things to do when I'm 30 or run a country. But do you see the shape now? Last time I mentioned, okay, frequency histogram is great, but at times only a few portion of people can recognize the shape right away, but there is another way to get the shape, and that is using a relative frequency polygon. So I'm going to give you every 2 or 3 minutes using the calculator. Let's see if you can come up with a relative frequency polygon.
That's what I'm saying. I think I put too many names. Like there's one, two,
Yes,
three, four,
that's
five, six,
visible.
7, and then 1, 2, 3, 4, 5, 6. I can't find that.
It's because of that one. There's like this.
Okay, so first we want to find or graph a relative frequency polygon or a regular frequency polygon. So difference for frequency polygon, we use the frequency. Relative frequency polygon, we use relative frequency. Regardless of what you use, the underlying shape will be the same. In practice, we will use this because relative frequency is probability. So I have data already from last time. So we want to get rid of the data. So either you can work hard or you can work smart. So instead of deleting each value in the list, you select number 4, we'll say clear list, second 1, second 2. That would get rid of all the data in list 1 and list 2. This is good for you because when you do problems in my math lab, even this problem, we have a lot of numbers, right? So do you really want to delete individual ones? No. You can do this in an instant if you know CLR list, which stands for clear list. So I'm going to plug in. The x-axis would be the class midpoints of the frequency. So what are the class midpoints? The midpoints between 42.5 and 47.5 is.
Shouldn't it be 41.5?
Yeah. Okay, 41.5 and 47.5 is. So it's 88, 89, right? Yes.
44.5.
44.5. So 44.5 for the first one. How about the second one?
51.5.
51.5. The third.
56.5.
Fourth.
62.5.
Fifth.
67.5.
Last.
74.5.
Do we agree?
Yes.
Okay. I'm going to use the relative frequency, so 7 over 45, 11 over 45, 16 over 45. Eight over 45. Three over 45. Last one is 0. Good. Graph. I guess something funky doesn't even make sense. So how do we get a proper graph? Zoom 9. So press zoom, press 9, and you will get a nice little graph. Yes. Now you can see it ends in 0 over here. I can make a change to the data even though we didn't do it. I'm going to pick a value prior to this. Let's say this is not necessary. I'm doing it so that you can see the nice shape. So 40.5 and 0. Graph. 2, 9. But it does show a point. That's weird. Why is that? Doesn't matter. Well, if you connect a line from here up and down, you can see a bell curve, right? Close to a bell curve. And that's exactly what we can do here as well. It sort of goes like that. Great. Now that is what we call a relative frequency polygon, because we are using relative frequencies. If we simply use frequencies, it's a frequency polygon. The next one is an ogive. So what do we need in order to graph an ogive? Come again, I can't hear you.
Every time I hit graph, it says that there's an error. How do I fix that?
What error are you getting?
Syntax.
More? Is it just saying syntax?
Yeah, that's it.
Have a whole bunch of these from algebra. Okay, you have to delete.
My sister's.
Yeah, you have to delete all of them and then just start. You have to tell your system not to touch your calculator. Put a mouse trap. Don't. You'll go to jail for assault. You would say my professor said so, now I've been accomplice. Both of us would be in jail. Okay, moving on. Don't again. So ODAR requires cumulative frequency, or you can use cumulative probability. I'm going to use cumulative probability because that's what we use in practice. Should we change both lists or just one of them? Obviously, we've got to change list 2 because we have relative frequencies. What we need is this. Agreed. Should we change list 1? Must we? Look at what we did last time.
Yeah.
Yes, why? Lily, right? No, Jasmine.
Yeah,
Other wood.
the right side of the boundaries.
The right side of the boundary. So we want the upper class boundary. So we have to change both of them. So we will go to number 4, second 1, comma, second 2. So the upper class boundaries for each class, so 47.5, 53.5, 39.5, 65.5, 71.5, 77.5, and the cumulative probabilities for each of them, 7 over 45, 18 over 45, 34 over 45, 42 over 45, 45 over 45, 45 over 45, and graph. Another forgiving graph. What should we do? Zoom. So that's a note. Good. So where is the biggest jump from here? Remember we did the problem last time where I said where did we have the greatest jump between those 2 points, and you can see that happening over here also. Yes. Jump this side, drop that side. Okay. Any questions on this? And why do we need an ogive or an empirical procedure? It will give us a cumulative probability. What do I mean by cumulative probability? If someone came up to you and asked you, what are the chances that a president's age will be at most 53.5? What would your answer be? At most 53.5 would mean less than or equal to 53.5. So what would your answer be? 0.
0%. It's not possible because there are presidents that are older than
It's not possible. At most 53.5, 53.5 or less. So you're saying there was no president who was 42 years old?
I thought you were saying like there was no president older than 53.
There are 2.
Yeah.
At most would mean 53.5 or less. So what are the chances of that happening? How did you get that, Everett?
I did 18
18 over 45. So this simply means 53.5, the upper class boundary, including below. So we have 18 over 45. What are the chances that we would have someone whose age is at least 72? 0. Does that make sense? You've got to understand the difference between at least and most. This will come later on to 20. At least means greater than or equal to, at most less than or equal to. So don't forget.
No. Sort of a creature.